Hey everyone, this is lesson 721 from our Integrated Math 3 textbook on determining missing parts of triangles. So this lesson continues the discussion on really how do you find missing side lengths, how do you find missing angle measurements from triangles, right? So, or given a triangle, can you find the missing information? So at this point, we've covered a number of methods. We have tools that we could use to find missing information. Here's kind of a summary of what that information is. So tools that we currently have. If we want to find missing side lengths, here are some things that we can use. And actually, I think all these are focused on right triangles. Right? It doesn't say right triangles, but for the most part, this is only right triangles. We could use Pythagorean theorem, a squared plus b squared equals c squared, or sometimes I've labeled it as leg squared plus leg squared equals hypotenuse squared. So in this situation, most likely you have two sides given to you and you're trying to find the third side. So that one's pretty straightforward. It's very focused on finding the missing side length of a right triangle. If you don't have two sides given to you, then trigonometry might be a good tool to use, sine, cosine, tangent, but it also depends on whether we have an angle given to us or not. So trig definitely depends on having at least one angle given to you besides the 90 degree. And then there were the special right triangles that allowed us to kind of skip the trig portion and even skip the Pythagorean theorem portion because there were special patterns that we saw with the side lengths. So 30, 60, 90, and 45, 45, 90 were the two special right triangles that we've gone over. If you just wanted to find missing angles, we could use inverse trig. So we still need to know your sine, cosine, tangent, but we'd be using the inverse version of that. And then technically you could still use special right triangles to find missing angles. If you are familiar with the patterns, basically your angles are going to be one of these. It's just about determining what they are based on the side lengths. So here's some options for us when we're trying to find missing information. So the question is, do you know when to use these? What information do you have to be given in order to use these tools? So we're going to go through some different possible types of problems you might get. So depending on what information you're given, would you know which tool to use? So here are 8 different possible problems that you might get. All 8 of them are giving you different information. So here's a kind of an overview of all of these. I'll zoom in so you can see it a little bit better. But let's start with maybe the first 2. If you're given all 3 sides, well, one, you don't have to find any missing sides, but there are some angles missing. So the question is, do we have any tools that are going to let us or allow us to find those missing angles? If so, which tools are they? That's something right now I'm just seeing if you could think about which tool you might use. Now, the only tools we have available to us are to find missing angles, inverse trig and special right triangles. And so I don't see a 90 degree angle anywhere here. So right now it looks like we really don't have any option, right? So right now there's none. So I'm going to go through each of these in more detail and kind of discuss what tools we might use and what tools we might not use. So first I'll go over them quickly, and then I'll go over them in more detail on the next page. So these are, and for the most part, when you're copying down this in your notes, one is you possibly could wait till either I'll show you all these at once and you can pause it and copy them all down, or on the next page you're going to see these problems again. So you could copy them then as well, or if you'd rather do it then. So second option is, well, what if they don't give you all three sides, but instead they give you two sides and one angle, right? They still gave us three pieces of information, except it was two sides and one angle. And in this case, it happens to be a 90-degree angle. So, well, that's perfect. As soon as I see a right triangle, to me, right away, I think of, wow, I have all the tools available to me. Now I just have to really pick which ones I want to use. So for the third one, here I have two sides and an angle. Again, two sides and an angle, but you'll notice, what's the difference between these, right? Two sides and an angle, two sides and an angle. Well, here it's a right angle and two sides. Right angle and two sides. Here it's those two sides and an angle between them. All right, so you'll notice here's two sides and the angle happens to be between them. And it's not a 90-degree. Maybe it could be. Maybe it doesn't matter. But all we know is for some reason it matters the position of that angle. So do we have any options? All right, and then here is another two sides and an angle again, except now we have two sides and an angle not between them. So here I have two sides and an angle. Let me highlight these for us. So I have two sides here and then the angle there. On the one before it, you'll notice the difference of where that angle is. And then I guess let me highlight this one. All right, so those are our three, it looks so far, yeah, so those three are interesting because two sides and an angle, but given to us three different ways. But are we going to use the same tool? Can we use the same tool? Only one of these happens to have a right angle. These don't. The question is, do we have another approach? Can I use really anything? All right, so I'll go into more detail of that one coming up. And so, okay, if we're not given two sides, then what if, here's three options at the bottom. So I notice all three of these say one side and two angles, one side and two angles, one side and two angles. All right, but yet they all look different. So here we're looking at a right angle again, and another angle. So let me highlight these. So I have, for sure I have a right angle, I have an angle, and an opposite side. Well, that reminds me of really our trig ratios, sine, cosine, tangent. So that one looks like a good possibility for that. On this other one, we have, I notice I have a side, but now I have two angles. There is no 90-degree here, so that concerns me because I really want to use either trig or Pythagorean theorem would be nice, but we have two angles. For sure we could figure out what that missing angle is. If it's 90, that would be nice, but I don't believe it's going to be 90. So the question is, how can we figure out this angle? Can we figure out the missing sides? And then the third one, again, we have a missing side. We have a side given to us, and those two angles again, but you'll notice the difference in the location. Here, this side is not between the two angles. Here, this side is between the two angles. So you'll notice the difference in location. All right, does it matter or not? And then the last one is, well, what if we're given just all three angles? Well, now that means we don't have to find any missing angles, but can we find the missing sides? Is there anything we could do to figure out what the missing sides are? All right, so that's kind of an overview. This is 8 different possibilities. You'll notice there's 3 of them that have 2 sides and 1 angle. And then there's 3 of them that have 1 side and 2 angles. Right? Every time on all of these, they're giving us 3 pieces of information. So 3 sides, it really didn't look like we could find the missing angles. 3 angles, it didn't really look like we could find the missing sides. Everything in between was like a maybe, or we had a good tool. So let's look at those a little bit in more detail. All right, so this is there's actually a resource page that I'm taking and writing on. So I'm going to just kind of show you, here's all 8 of those that we're going to go over. And so the first one, so if you haven't copied these down yet, this might be a good time to start copying these down. If you need to pause it at any point, then feel free to do that. So here I have all 3 sides given to us. Now we want to see if we could find the missing angles. So is there anything we have, any tools we have? Not yet, right? We will figure out, we will learn a new tool coming up to see if it helps us find the missing angle in a problem like this. All right, and let's do B. So let's start with a right angle and 2 sides. All right, so this was the second one. Here I have a triangle that is a right triangle. So as soon as I see that, I have options. 2 sides were given to us, 4 and 5. So that tells me I could use Pythagorean theorem. The angles, if I want to figure out the angles, which I did here, I would have to use inverse trig. So anytime you're going to find angles, you're pretty much going to be using inverse trig all the time, unless for some reason it's a special right triangle. But even if it is a special right triangle, inverse trig would always work as well. So that would be this portion right here. So you can see I used Pythagorean theorem, and then I used inverse trig to find this. So I'm just showing you the possible ways you could solve this. There might be more than one way, but I'm really just to show you that we do have the tools. All this stuff we've learned. All right. Let's see. C says we have 2 sides and an angle between them. So let me remind you what this looked like. Let me move this out of the way. So this is what we had, 2 sides and an angle in between them. We really don't have a tool here, but a strategy, let me put this back. A strategy that I thought might be useful is, if we don't have a right angle, why not create one? And the best way to create one is to add a line. Basically what I did is I cut this triangle into 2 triangles. So when I did that, when I cut into 2 triangles, it now gives me 2 right triangles. So that's awesome, because I noticed I have an angle here, which is 60, which means I've just created a 30, 60, 90 triangle on the left side. So once I know I have a 30, 60, 90 triangle, right, which I have listed at the top, then I could find the missing measurement. So if this is 14, the short leg has to be 7. So that's just this portion right here on the left side, which means I know the height has to be 7 times the square root of 3. Now, once I know the height, and I know this total length is 20, which means this has to be 13, because 7 and 13 is 20. So I know this is 13, and I know this is 7 root 3. If I want to know the hypotenuse of the triangle on the right side, because it is a right triangle, I could use Pythagorean theorem, right? That's this, and I could get an answer there. So that might simplify or might not. I just left it in the square root, really just to show you it's possible. And then there is an angle in here that we could still find. And then that we could use like inverse trig. And then if we could find that, then we could probably also find this angle up here and then combine it with 30. So it seems doable with using these three tools. Everything we've covered before. I think the only thing new maybe I'm sharing with you right now is this idea of cutting it into two triangles. Not equal triangles, not necessarily, but just two triangles where I draw a line that is perpendicular to the base. So that creates this 90-degree angle. You'll notice I didn't draw the line over here, right? That doesn't make sense. But it has to be straight so that this is a right angle. All right, so that's one approach with really all the tools we already have. If we have two sides and an angle not between them, so this is a similar situation except instead of maybe the 5 being over here, it's been moved over here. Now, even if I draw a line, if I cut this, I'm still, technically, there's a possibility I could use some trig, but this 7, right, the 7 is this whole length. As soon as I cut this piece off, I don't know how big that is. I don't know if it's 1, 2, 3. So I have a strategy to use, but it doesn't seem like it's going to take me anywhere. So we're not here yet. So we're going to hopefully get to the point where I'm going to give you a tool that's going to let you solve this one. All right, so that is, we've gone over the first 4. And then, let's see, here is a right angle and another angle and a side. All right, so in this situation, because we have a right angle, that's always the easy part. As soon as you see right angle, chances are we have a tool to solve it. And in this case, it happens to be a 30 degrees, so this is 30, 60, 90. Technically, if you don't know your 30, 60, 90, then you could also use your trig ratios as well. All right, so you could have used sine, cosine to solve this. But since I noticed a 30, I figured might as well use our special right triangles. So since the hypotenuse is 18, the short leg is going to be half of the hypotenuse. So that's why this is a 9, right? And 18 is twice as big, and this is 9 root 3. All right, so review your 30, 60, 90, or let me know if you have questions on that. Two angles and a side not between them. All right, so similar situation. Let me remove all the writing I already have here. So here's what the problem looked like before. We have two angles and a side, two angles and a side over here. This is not a 90 degrees. It might look like one. Common mistake is some people think, oh, that's 90, but these three angles don't add up to 180 degrees. So that wouldn't make any sense. So this is going to be some other angle. So the question is, how do we solve this? And so, like I kind of showed you earlier, well, what if I cut this into two triangles? That's a good strategy that'll work here, mainly because these are special right triangle angles, 30, 60, 90 on the right side, and 45, 45, 90 on the left side. So those are two tools we have to use. So let me put my work back here. And so because this is a 45, 45, and I guess let's start with really the 30, 60. Since this is 18, this short leg, which is the height, has to be 9. And then the long leg would have to be 9 root 3. So that's how I figured out the right side. Once I knew this was a 9, then that means the other side of the 45, 45 has to be 9 also. And then the pattern is 9, 9, 9 root 2 for the 45, 45. So now I have all side measurements. If we add these together at the bottom, they give us 9 plus 9 root 3. All right, and so since we already know these angles because of the special right angles, we could add those together to be, what is that, 105? So that's a 105 degree angle. All right, so if you didn't know your special right triangles, you could always end up using Pythagorean theorem at some point or combine with it. All right, and then if we have two angles and a side between them, well, in this situation, the only thing that we can use, I didn't mention it earlier, but it's just kind of given that you already know Triangle Angle Sum Theorem, right? All three angles in a triangle add up to 180 degrees. Well, if I know two of them, you should be able to figure out what the third angle is. So that should be hopefully easy. But what about these sides? Is there anything we could do to figure out the missing sides? Now, if this happened to be a right angle, then we could do possibly a little bit more. But this is not a right angle, so then what can we do? We could try to cut it into pieces. What if I cut it into two right triangles? Is that an option for us? Well, it doesn't seem so because I still don't know this side. I don't know this side. I even don't know what these are because I don't know how I'm dividing that 5. Right? So I don't know if it's not splitting it in half. So I still don't know really enough side information for us to use Pythagorean theorem, trig, or special right triangles. All right, so we're not here yet, and then so hopefully we're going to learn how to solve that one. And then if you're given three angles, really there's too many possible solutions to list out. Right? So if for some reason we take this, right? Remember, if I take a triangle like this, not all triangles, these all have the same measurements, but they could be different sizes, right? So I don't know if I'm talking about a triangle that's this small or really a triangle that's bigger. The side lengths could be really anything, but the angles, even if I have a big triangle like this, you'll notice the angles still fit. Those angle measurements always fit. All right, so even if I make it small, all right, definitely smaller, that's still 60, that's still 75, that's still 45. So there's no way we know what those triangles could be. So too many possible solutions. All right, so what we're really focused on is, since we kind of have strategies for most of these, for the last one, it doesn't really seem like there's going to be a tool to help us. For the first one, so we're going to see if it's possible we could do that, which I think we will. So that's one of them. All the rest, we had some method. The ones that involved, let's see, this one where we had to actually cut it, and this one we had to cut it. For some of you might feel like, you know what, that just seems so complicated. Like, I wish there was an easier way. Well, hopefully, if whatever strategies we could find to work for these, right, so for these strategies, we could apply them to these as well. So I think that's our kind of our goal. So we're going to learn some new tools, maybe more powerful tools that could get the job done for a variety of situations. All right. I think that's it for now.